Today we're going to look at factorising algebraic expressions. So factorising is the opposite process to expanding, and here are the steps that we can complete to actually factorise an expression. So we need to firstly find the highest common factor of all of the terms in the expression. Okay, it has to be the highest common factor of all of the terms if we're going to factorise the whole expression. Then, for the second step, we take each term and divide each term by the highest common factor. Then we need to compensate for this, because if we just divide everything by the highest common factor, we're not left with the same expression that we started with. We're not left with an equivalent expression at all. So we need to compensate for this division by multiplying then the whole expression by that highest common factor. We then need to check the factorisation by expanding it. If we check the factorisation, we expand it out, then we can actually see, yes, we've got an equivalent expression that we started to what we started with. So here are some examples. The highest common factor for an expression can be just a rational number, it can be a variable, or it could be a combination. It could be actually an expression in itself that is common, that is the highest common factor for all of the terms. So here, if we have a look at 2x plus 10, the highest common factor of 2x and 10 is just 2. So if we divide the whole lot by 2, divide x by 2 and we just get x, and divide 10 by 2 and we get 5. So x divided by 2 is 2x divided by 2 is just x, 10 divided by 2 is 5. Then, if we multiply the whole expression by 2, we've factorised our expression, and we can double check and expand it out to see that we've got it right. 2 times x is 2x, 2 times 5 is 10. So we can see that the expression is equivalent. Let's have a look here. X squared plus 5x, the highest common factor of both of these terms is just x. So x squared divided by x is x, 5x divided by x is 5, so we're left x plus 5, okay, and then we need to multiply the whole expression, x plus 5, by the highest common factor, which was x, okay. So here, the HCF was 2, here the HCF is just x, okay. So we've gone x squared divided by x is x, and 5x divided by x is 5. Here, last one, 2x squared and 10x. Now the highest common factor of both of these is 2x. I can divide this by 2x and I can divide this by 2x. So the HCF is 2x. Okay, so 2x squared divided by 2x is just x left over, and 10x divided by 2x is 5. So we're left with 2x multiplied by x plus 5. Let's just double check that if we expand this back out, we get the expression that we started with. So 2x times x is 2x squared, 2x times 5 is 10x. Alright, let's have a look at these examples here. We've got to factorise these following expressions. So let's start at the top here, 40 minus 16b. The HCF here is going to be 8, so the highest common factor is 8. If we do 40 divided by 8, that's 5, and minus 16b divided by 8 is minus 2b. So we're left with 8 times 5 minus 2b. Let's just expand it out very quickly to see that we can check it and we can see that we've done it correctly, because remember that factorisation is the opposite process to expanding. So if we do an expansion of a factorised thing, then we should get what we started with. So 8 times 5 is 40, very good. Minus 2b times 8 is going to be minus 16b, which is what we started with, tops. So here we go for the next one, minus 8x squared minus 12x. The highest common factor is going to be a negative, because we've got both of the terms here are negative. So minus 8x squared. They both have x, so x is going to be a highest common factor, and they both have a factor of 4. So 8 and 12 both have a factor of 4. That's the highest common factor that they share. So here, the highest common factor is going to be minus 4x. So if we go minus 8x squared divided by minus 4x, we get a positive, because a negative divided by a negative is a positive. We get positive 2x, and negative 12x divided by negative 4x, once again it's going to be a positive, and we're going to get 3 for that. Let's double check. Let's double check by expanding out. So negative 4x times 2x, negative 4 times negative 2 is negative 8. Negative 4 times positive 2 is negative 8, and x times x is x squared. So we're right on the first term. Negative 4x times 3, if I've got negative 4x times 3, it's going to be a negative, and it's going to be negative 12x, which is what we've got here. That's the answer that we've got there. So that's all good as well. Here we've got now something slightly a bit more challenging maybe. We've got 3x plus y plus x plus y. So you can see that both of these terms have the x plus y as common. That is the highest common factor, x plus y. So if we divide x plus y, this first term by x plus y, we're going to be left with just 3. Okay? Because if I go 3 x plus y divided by x plus y, that x plus y divided by x plus y becomes 1, and we're just left with 3. So that's the first part. That's what we'd be left with by dividing by, here, the highest common factor, x plus y. So 3x plus y divided by x plus y is just 3. Then we've got here x plus y. So if we go x plus y divided by x plus y, we're just left with with x. So here you can see the 3 comes from here, the x comes from here, and we're left with, this is the highest common factor that we've taken from both terms, divided both terms by, and we're left with 3 plus x in brackets there. So this is the expression with the highest common factors divided by both of the terms. Okay, let's have a look at expanding it out to make sure that we've done it correctly. So I'm just going to, we can very simply have a look here that 3 times x plus y is 3x plus y, plus x times x plus y is x plus y. Okay, there, very simple. The last one here, 7 minus 2x minus x times 7 minus 2x. So it's pretty clear that both of these terms here have 7 minus 2x as their highest common factor. However, it's not very clear exactly what is multiplied by the 7 minus 2x, what the component that's left over is going to be. But we know that if it's not multiplied by anything else, then it's the same as multiplying it by 1. So this part here is the same as 1 times 7 minus 2x. So if we in fact divide this term by 7 minus 2x, we'll be left with 1 here. Okay, so we're left with the 1 from here. Then if we have minus x and we divide it by 7 minus 2x, we'll just be left with that minus x left over. So here, the highest common factor is multiplied by the expression that we have left over, each of the terms with the highest common factor divided by both of them, and we're left with 7 minus 2x times 1, which is just the 7 minus 2x, divided by 7 minus 2x, because we've divided by the highest common factor, we're left with just the 1, and here we're left with the subtract x. So we've got here 7 minus 2x multiplied by 1 minus x. So let's just double check, make sure that we've factorised this correctly by expanding it. So here, if we've got 1 times 7 minus 2x, we're left with that. Minus x times 7 minus 2x is going to be minus x times 7 minus 2x, which is what we have left over there.